Good morning, students. Today lecture about Boolean algebra. Boolean algebra is nothing but a mathematical logic. It is different from ordinary mathematics. That is, if we add in decimal, if we add 1 plus 1, we get 2. Okay. If in binary, if we add 1 plus 1, we get 1 0. But in our digital electronics, if we add 1 plus 1, we get 1 only. So this is the mathematical logic. So this is called Boolean algebra. So here we get 1 plus 1 equal to 1. So this is called this mathematical logic is different from ordinary mathematical operations. That is okay. Now we will see the some mathematical postulates and theorems in Boolean algebra. That is fundamental postulates and laws of Boolean algebra. So first postulate, identity postulate. Identity postulate here A, A, B, all are variables, all are input variables for a system. So into A, B, C, these are all variables, and plus dot, these are equal, these are all operators. Okay, generally these are all variables, plus dot are operators. Okay, next 0 and 1 are constants. Okay, now we will go to the postulate. The first postulate is identity postulate. That is, if you add, that is add a plus 0, that is variable plus constant 0, or constant 0 plus a variable equal to a. So if you add a plus 0 or 0 plus a, we get a. Similarly, if you multiply a dot 1 or 1 dot a equal to 0, this is the identity postulate. We can verify with an example. I put here, I write the example in this area. That is, if you put a equal to 1, substitute this a in the identity equation, that is 1 plus 0 equal to, if you add 1 plus 0, we get 1. Similarly, 0 second equation, that is 0 plus 1 equal to also 1. Just a minute. Similarly, if you multiply this a with 1, that is a equal to 1, 1 into 1 equal to 1, 1 into 1, 1. Here this is a, and this is a, and this is a, and this is a. Substitute a equal to 1. Here we substitute, we get same answers. That is, if you substitute 0, if you substitute 0, here 0, the answer will get 0. That is a. So this is also a. So if we substitute 0 here, 0 plus 0, 0. Similarly, if we substitute 0 here, 0 multiplied with 1 is 0. Here, if you substitute 0 here, 1 multiplied with 0, answer is 0. So this is called identity postulate. Okay. Next, cumulative postulate. That is a plus b. If you add a plus b, that is equal to b plus a. Similarly, a dot b, a multiply with b is equal to b multiply with a. This is called cumulative postulate. Uh, 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 by substituting on an example, we can understand that is a equal to 1, b equal to 0. Substitute this in this equation, that is a equal to 1. So 1 plus b equal to 0, that is equal to 0 plus 1. So this answer is 1 and this answer also 1. So we can verify the cumulative properties by using this example. Similarly, a dot b equal to b dot a. Okay. Next, distributive property, that is a dot b similarly distributive property, that is a dot bracket b plus c equal to a dot b plus a dot c. Similarly, a plus bracket b dot c equal to a plus b into a plus b. Sorry, a plus c. This is distributive property. Just memorize this property. We will see the examples later. Okay. Next, similarly associative property. This is a plus b bracket b plus c is also equal to b plus a bracket of a plus b plus c. Okay, similarly this one, and this is one of the important postulate, that is a plus a bar. A bar means complement, bar means complement of a. Okay, so a plus a bar equal to 1. Similarly, a multiplied with a bar equal to 0. That is a plus complement of a equal to 1. A multiply complement of a is 0. We can check this with an example. Put a equal to 1 in this equation. We get a is 1. A bar means complement of a. That is complement of 1 is 0, equal to 1. So 1 plus 0 equal to 1. Similarly, if you substitute a equal to 0, then here for a we substitute 0, a bar complement of 0 is 1. This is also 1. So the first a plus a bar equal to 1. This is verified. Now go to a dot a bar equal to 0. If you substitute a equal to 1 in this equation, that is a, complement of a bar is 0. So 1 dot 1 multiplied with 0 is 0. Similarly, if you substitute 0, so complement of 0 is 1. If you multiply 0 with 1, we get answer is 0. So second postulate also verified. So this is complement postulates. Okay. Next, basic theorems. These are all postulates and laws and theorems are used for reduce the Boolean expression. Next class we will see that how to reduce the Boolean expressions. Boolean expression means it is the output of a digital system. So we have to reduce number of components. For that we have to memorize these postulates and Boolean expressions. So it is very very important for reducing the Boolean expressions and following classes. Okay, so you have to memorize all the things. You have to by God all the things. So it is very very important for digital electronics. Okay, next, basic theorems. So these are all also we can call as a theorems, and some important theorems is idempotency theorem. Idempotency theorem. In the theorem, that is a variable is added with a variable, then the answer is a. Similarly, a variable is multiplied with a variable, the answer is a. We can verify this equation. For example, a equal to 1. So, in this equation, 1 plus 1 equal to 1. Okay, that is 1 OR gate with 1. So, plus means OR gate and multiplication means AND operation. Plus means OR operation, dot means multiplication, multiplication means AND operation. You have to remember this. So, here 1 OR with 1 equal to answer is 1. Okay. Similarly, 1 AND with 1 is 1. Okay. So this is idempotency theorem. Okay. Similarly, next a r with 1 equal to 1. So just like okay. Uh, okay. A r with 1. That is, if you put 0 plus 1 also 1. If you put 1 plus 1 also 1. Okay. This is the idempotency theorem. And similarly, a dot 0 equal to 0. So, and a is AND with 0. If for AND operation, AND gate operation, any input is 0, the output is 0. Or we can say that if any number is multiplied with 0, the answer is 0. So similarly, we can say that AND operation, any input, any one of the input is 0. So for AND operation, 0 is a one input, A is another input. If you get AND operation output, definitely you get 0. Okay. Next, these are all very important properties. Sorry, theorems. So we got by got this theorem. Next, involution theorem. So this is also very important theorem. Involution theorem. That is a double bar. Double bar means complement of complement. Complement of complement A. So double inversion, double complement of A equal to A. Okay, you have to get this one. Next, absorption theorem. So A plus AB. So A market here on AND gate. AB, it is A dot B like this. Okay. So A OR gate here AND gate. If the expression have A plus AB, then we can directly write as A. So we can verify this. If you substitute A equal to 1, here A equal to 1, if you substitute B also 1, the answer is 1 into 1, 1, 1 plus 1, 1, the answer is 1. That is whatever we give in A, that gives here also. Okay. Similarly, if you give 0, here also 0, so 0 multiplied with B, anything. So here 0. So 0 plus 0 is 0. So whatever given A, it gives the result. So that A plus AB equal to A. Okay. So it is very important property, very important theorem. Okay. So A plus AB equal to A. And similarly, A plus A bar B equal to A plus B. Okay, so this is also very important theorem. So A plus A bar B equal to A plus B. We will see later about this property. Okay, next, De Morgan's theorem. So this is also very important. Sometimes, many times they ask in 2 mark questions. So we have to remember this very important. Okay, De Morgan's theorem. In this De Morgan's theorem, complement of a product. This is A dot B. A dot B means product or AND operation. So complement of AND operation. A bar means complement. Complement of AND operation is equal to sum of complements. So sum of complements. Similarly, complement of OR operation is sum of product of complements. Okay, so and the dot is converted to R, and complement is split into two variables. Complement is split for two variables. Similarly, that AND operation is converted to OR operation is converted to AND operation. Then the complement is split to two variables A and B. So it is very important property. Complement of AND operation is equal to sum of complements. Next, complement of OR operation is equal to product of complements. Product of complements. This is very important property. Okay. Next is duality theorem. This is also very important to 2 marks. 2 mark. In duality theorem, what it states that if in this expression we have some AND operation or operation. So for duality theorem, we have to change each OR operation to AND operation. So similarly, change each AND operation to OR operation. If any 0 or 1 in that if any 0 or 1 constant in that expression, we have to take complement. So complement of any 0 or 1 in an expression. So we have to see one example for duality theorem. This is also very important theorem. Many times they ask in 2 marks. One example for duality theorem, that is okay. Apply the duality theorem in this expression. So first of all, if any if change any OR gate to AND gate, here we get only AND operation. So second, change each AND gate to OR operation. So here AND is changed to OR operation. That is AND is changed to OR. That is A plus B bar equal to, and if any constant, we have to take complement. So here is constant 1 is 1. So we have to take complement for this constant. So for one complement of 1 is 0. So this is the duality expression for this equation. This is the duality expression for this equation. So it gives same duality expression. Okay. So this is also very important theorem. This is also very important theorem, and these are all very important for reduce the Boolean expressions. Okay. Okay. Thank you. We will see the some examples next.